All right. Welcome everybody to this evening's webinar. My name is Anthony. I will be doing the this webinar on Volkswagen Audi turbocharging control and power loss. If you guys have spoken to me before, I am a diagnostician here for VAG. Um, Turn off my pen here. We'll need that in a bit. But yeah, so we're going to be talking a little about the technology that Volkswagen uses. A couple things that we'll be talking about as well, the different engine types, uh, what as far as which cars use what engine, and then we will also be talking about the design and operation of the turbo systems and some diagnosis and common issues. All right. One thing that we'll probably not be talking about is the diesel turbos, only because one, diesels are, one, Volkswagen got a big slap on the wrist for that, and we actually don't use those engines anymore unless we are outside in the rest of the world. But here in North America, we will be sticking strictly to the gas engines. All right. So let's go ahead and get it started on here. Um, as I mentioned, the topics, I'm actually going to turn my camera off too as well, make it a little easier. But as we're talking here, the thing that I will be going over is VAG engines utilizing the turbo technology. Okay, we need to get ourselves a little bit familiar with which engines are using what, and then we will be getting onto the design and operations of the turbo systems. Okay, obviously, we're going to be talking a little bit about the turbos. Um, and obviously common issues like the common faults and diagnosis with those faults. All right. So Volkswagen and Audi, as far as their turbo engines go, right? They have multiple four-cylinder engines that are utilizing the turbo. Okay. Obviously, they use the four-cylinder turbos because it is a economical engine as far as fuel economy. And when you put a turbo on it, it has the capabilities of producing a little bit more power while at the same time not being a quote unquote gas guzzler, right? But as we do know, Volkswagen and Audi also do have their grassroots and also racing. So they do have some sportier engines. They do have some bigger engines with turbos. Okay. So a couple things to get familiarized just because this is an engine that we see across both Volkswagen and Audi platforms and to some degree even some of these into their other platforms. Porsche uses a lot of the Volkswagen engines. Okay. They do use the 2 liter, they do use the V6 turbo and also the V8 turbos. Okay. And by V6 turbo, I mean, yes, we have a V6 turbo and then we have a V6 twin turbo and then also the V8 twin turbo. I'll be going a little bit over the differences on those as well, because obviously there are differences when it comes to those engines and turbo setups as well, right? Now, four-cylinder turbo, we have the 1.4 liter engine that debuted in the Volkswagen Jetta hybrid. It was actually in Europe in the Polo before it came here to North America. After that, they started using the 1.4 in Volkswagens and the Jettas. It was an option along with the obviously the 1.8 and 2 liter. Um, the newer Jettas, the Passats and the Taos and all that, the Passat uses the 2 liter, excuse me, but the newer Jettas, the Taos, they do utilize the 1.5. Which is essentially the same thing as the 1.4. The stroke and bore are slightly different on that engine, but when I show you the images and we talk about the engine, it's going to be essentially, if you take a look at the same thing. Okay. As we both know, or as we all know, the 1.8 is also what they were using in between 2014 to 2018. Okay, they use that in the Jettas. They were using that in the Passats previously, and they were also using that in the Golf. All right. Uh, Audi was also using them as well. And then basically the other thing that you want to take a look at is also the 2 liter, right? The 2 liter turbo is probably the most commonly used engine. Okay. The 2 liter engine, obviously, we have had various instances and multiple generations of. And we are up to generation, I want to say 3.5. Okay, I always consider the half because it's right at the latest fourth generation engine is slightly different, but it's not. So it's about the same. That's why I call it a 3.5. Okay. So that's the 4 cylinder. We do have the 5 cylinder turbos, and then also the V6 turbo and V6 twin turbo, and then also the V8 twin turbos. Okay. So first engine here is going to be the first one we're going to talk about, obviously, is the 1.4 and 1.5 liters. All right. So other than previous generation, the 1.4, one of the things that this engine started, this turbo setup, was essentially a air to water intercooler. See Caesar raise his hand. Uh, okay, I don't think we have anything there. Um, so basically, the next thing on here, so 1.4 and 1.5. So 1.5 is the latest generation of the 4 cylinder turbos. Like I said, they're using these in the Taos and also the newer Jettas. They are having some issues with head gaskets, but essentially the turbo issues that you've seen in the 1.4 are also the same. So we'll talk about that as well. All right. Now, if you take a look at the way this thing is set up on the 1.4, you have the turbo sitting in the back. All right. And essentially, there is no front mount intercooler like the other vehicles. This charge air is going straight into the throttle, where the throttle is connected to the intercooler, all right, which is also the intake, all right. So essentially what's happening is that they're saving a lot of space. There's less turbo lag on here, especially since this is a smaller engine. And then essentially what you're doing is you're cooling that air right as it's going into the engine. And we're going to be talking about that as well on why the turbos do that. Okay. So 1.4, we did have some turbo issues, which we'll talk about. 1.5, same issues as well. More of the issues that we see on the 1.5 are more engine issues or engine related issues, not as many turbo as far as failures other than the wastegate actuator, which, it's just poor manufacturing. So the other 4 cylinder engine is going to be the 1.8 and 2 liter. All right, these are both the 4 cylinder engines as well. So the 1.8 and the 2 liter are exactly the same. All right. The only difference is between the 1.8 and 2 liters was the stroke and bore of the actual engine. Okay. The design, everything else, the block, almost everything is exactly the same. Cylinder head, everything is coming down to the turbos. The turbos they used were slightly different. They have a slightly bigger turbo in the 2 liters. Power, obviously, power output is different. They use the 1.8 and 2 liters across both Volkswagen and Audi. The 2 liter themselves, they've used that across Volkswagen, Audi, and Porsche. Okay. Now, the thing with this, it's the traditional, like I said, there's on the, we're going to probably talk more about the 2 liter because the 1.8 was essentially just 2 generations or 1.5. The 2 liter, it's already, like I said, 3.5 generations in, right? The first 2 liter turbo would be the BPY belt driven, all right, our true first generation. And then you had the first generation chain engine, CCTA, CVA, all those, which is technically the second generation. And then we have the EA 888 engines, which is going to be the third generation, which is essentially what all the newer engines are derived from. Okay. Now these engines are what they call modular engines that Volkswagen describes. So everything can be replaced easily, swapped over, etc. But we all know working on these engines that that is not necessarily the case. Okay. Now, I want you to notice one thing. So I got a 1.8 here. This is an image of a 1.8, and the 2 liter looks identical. Okay. Now, the one thing, if you've noticed the difference between going from a BPY to a CCTA and to the third generation engine is now the exhaust manifold is now a secondary part. It's now included and inclusive with the cylinder head. You can't replace it. Okay. So it's actually part of the cylinder head. The turbo bolts directly to the cylinder head. And now what it means is you have a turbo that spools up quicker. There is less heat soak. Essentially, all that. There's no waste, essentially. And obviously, one, it's going to make replacement easier. Two, the other thing that you're going to have is less components to replace, less broken parts, right? But the only thing that sucks is if there is any concerns, essentially, you know, a cylinder head replacement can be the cause, which if you guys have seen on the 1.8s and the 2 liters, they do have secondary air issues, but that's a whole different story, right? These are valve stem seal issues, leaking oil into the combustion chamber, and it's blocking the secondary ports, which secondary ports, we do see some concerns, right? Because those secondary ports are connected and they do make contact with the turbo. All right. Now, another thing just to kind of talk about, we'll bring it up a little bit more on the 2 liters, is that the way the style of crankcase breather is on this new 2 liter engines, right? Where the head is internal, or the exhaust manifold is internal, and the crankcase breather, it's no longer just a piece on top, right? In order to test these things, you have to pull the breather out, right? It's just a little thing. The problem with these now is what we're dealing with is the way they have the purge valve set up and everything, and the way the engine is boosted. We now have excessive crankcase pressure that can depend on failures amongst the actual engine itself. And then we've seen multiple things going on with it, which we'll talk about as well. That may not necessarily be the actual turbo or boost pressure issues, but we've seen some of them and they are related to each other, along with evap and the crankcase breather, which we'll go over a little bit more as well. 2.5 5-cylinder turbo engines. All right. So these were essentially leftover 2.5 engines that Volkswagen had. They beefed it up, obviously. Different pistons, rods, essentially cylinder heads the same. They slapped the turbo on it and they threw this into the TTRS and the new generation RS3s. Okay. Uh, Essentially, those were the only ones that really ran this engine. Uh, Lots of tuners love it. For the most part, it's a bulletproof engine. Um, Not too many issues with the turbos on these, but like I said, these were only in the RS versions of two particular cars. These are, tuner friendly cars. Make a lot of power, make even more power when they're tuned. But essentially, this was the engine that they put into those two RS cars. Okay. Now we have two other V6 engines here. Okay. Most of us are familiar with the V6 supercharged engine. All right. Now, the 3 liter single turbo engine is the exact same engine, except instead of a supercharger in the valley, now they run the turbo. Okay. Actually, it's not exactly the same. Obviously, the heads are reverse flow, but it's the same design. They reverse the heads and they now have a turbo in the valley. Okay. The block and everything else is essentially the same. The biggest difference is, and now you have the 2.9, right? Now, here's the crazy part and maybe even weird part, whatever you want to say. The 3 liter V6 turbo engines were in the S4s. Okay. They were in the S5s. Okay. They were in the A6, in the A7. Okay. And They were also in like the I want to say A8s as well, and A7s, but then they switched to the 2.9. Now the 2.9, it's kind of similar to when Mercedes switched to from the 5.5 liter down to the 4 liter, right? The only difference is this is going to be a V6 twin turbo and is now 2.9, about 100 horsepower, 100 foot-pounds of torque difference. And they are using the 2.9 in the RS5 and also the S6, the S7s, and the RS4s. All right. So little key differences here. The other thing with the 2.9, it also runs an electric turbocharger. Okay? If you guys have not seen the electric turbocharger, what it's supposed to do is help maintain boost and help the vehicle on lower RPMs. All right. Kind of think F1 technology, but the difference is that it's got an electric charger on the bottom because the 2.9s are also in the mild hybrid 48-volt system. Okay, so the electric turbocharger down here at the bottom of the block is 48-volt driven, and it basically will end on lower RPMs and offload. Okay, this will help the turbo spin. So that is the electric electric turbo on it. Um, the electric turbos do have some issues. Most of the time, it will throw a fault. There is a module on that, but on those electric turbos, it's not going to cause a P0299 fault or a issue with a low boost condition. Okay, we've seen low boost conditions with these engines. We've seen multiple things going on with it, and we're going to talk about that because it's actually something that's very common that we started seeing. Now we have the 4 liter V8 turbo engine. All right. So this is in the big boy. This is going to be in the RS6. Okay. This is going to be in the previous version, the RS7s, and the P and also the uh, S8 and S6 previous versions. Okay. So that's prior to 2020. Everything after 2020, S6 and S8 is going to be running the V6 twin turbo. All right. So the 4 liter V8 twin turbo was used on the previous generation S6, S8 up to 2020. It's still the same current engine that's in the RS6 Avant and also in the RSQ8. Okay, which we all know is also the same as the Lamborghini Urus. All right. So this is what they're running on there. Um, these things have seen multiple issues, obviously, as well. I'm sure some of you guys have seen the ones that have had issues. Okay. So you'll see multiple things going on. Most of these are going to be oiling issues. There's going to be some things that Volkswagen has considered normal, but at the same time, once you see what happens because of the quote unquote normal condition, you'll see that we have seen multiple premature failures on the 4 liter V8 twin turbos. Okay. So obviously we're going to talk about a little bit design and operation of the turbo systems before we get into it, because obviously we need to know how the turbos work. Okay. Some of you may know, some of you may not, maybe a little rusty, but obviously turbos are a way of essentially boosting the engine's output, right? Especially like on an engine that would not be making that same type of power, hence like the 1.4, 1.5, 1.8, 2 liter turbos, right? You've seen some of these that are pushing out, 300, 400 horsepower once they're tuned or whatever, but even stock, right? You see some of these, the third generation 2 liter turbos, they're making, I think Audi is making 261 is what they're rated at. Volkswagen is making about 250, somewhere around that. And this is from a little 4-cylinder 2 liter engine. Now, obviously the V6 twin turbo, the V8 twin turbos are going to be making a lot more. And the turbos are smaller, obviously, to compensate for the torque. And essentially at the same time, what they're doing is fuel economy, if as much as you can say, it helps with that. Okay. Now, to understand the way the turbos are set up, right? We're gonna talk about this, right? Because we need to know exactly how the turbo works, right? So compared to the supercharger, obviously the supercharger is belt driven, right? You have a technically a turbine, right? Or root style, and then you basically will have a belt that drives that, right? Two different styles superchargers. What we use is a root style supercharger, but essentially the way the system works, it's very similar. Now, with the turbo, we're going to use exhaust gas to spin the compressor, right? Or the turbocharger side of the turbine, which is the hot side of the turbo. Okay. So as the exhaust gas is coming out of the manifold or out of the cylinder head, it's going to spin the turbocharger turbine, right? Now, that thing can spin as much as the exhaust gas that comes out. Okay. We need to regulate that. And how we're going to regulate that is going to be the wastegate actuator. Okay. So we're going to get to that wastegate actuator part, but obviously talking about the turbo part. Okay. As the exhaust gas comes out, it spins that turbocharger turbine. Okay. As that turbocharger turbine spins, it's connected via a shaft to the compressor side, which is on the cold side of the turbo or the intake side. All right. So what that's going to do is that's going to pull in intake air, and the wheel on that, the reason they call it the compressor wheel, because it's going to compress the air. And as it compresses the air, it's going to compress it into the cylinder. And as it compresses the air, increases the amount of air entering the cylinder versus just having a throttle body suck in air. Now we're forcing air, hence force induction, and pushing that air into the cylinders. Okay. That being said, though, as that compressor is spinning and as it's compressing the air, when air is going through and being compressed, you're going to get a rise in temperature. Okay. Now, that being said, when you get a rise in temperature on the intake air, you're going to have a lot less power, right? You guys ever notice if you're driving through the desert, your car feels sluggish, right? On a non-turbo. But if you have cold air, you're driving on a nice, brisk, cold morning, driving through the mountains, whatever the case, and it's colder air, you're going to get more power because you want that cool air has a higher density, right? So that fuel, air to fuel mixture entering the engine is going to be greater. So by that, you're going to have more power. So that's the reason why we have these turbos in the car, is to increase the output of power, but for the same sized engine or smaller displacement engine. Okay. Now, what Volkswagen Audi use is going to be an intercooler, which a lot of manufacturers use to cool that air down. All right. Now, a lot of the V6, the V8s, okay, and the 5-cylinder turbos are going to use an air-to-air intercooler. Okay. Even the 2 liters. Only the 1.5 and the 1.4s use a cool air to water intercooler, which uses coolant to cool down the air that's going through. And that way you have that cooler air going into the intake. All right. But like I said, with turbo, obviously we need a way to control the exhaust, because in theory, you can just keep spinning and that turbo can just keep on boosting. Well, one, if we know the way turbo works or the way boost works, if you keep increasing boost and you're increasing that air, right? Obviously, in order to maintain the vehicle operation, maintain the drivability of the vehicle with all that additional air, what do we also need? Fuel. Okay. Now, manufacturers have this tuned and dialed to a point where you have X amount of fuel going in with X amount of air. Okay. One, it's because of emissions, right? You're going to have higher emissions if your car is making more power because you're putting more air in and more fuel. Now, that being said, there needs to be a way to control that, because the way manufacturers have tested the car and tested the turbo, they have now looked at, right? They've done multiple testing and they've seen, okay, well, with this much pressure in boost, it's going to need this much fuel. And then after that, what's going to happen is, hey, this is the right amount. We're going to be right at the cross point where just the right amount of power, right amount of air, right amount of fuel, and our emissions are going to stay low, because that's what they want, right? Obviously, tuners want more power, manufacturers want adequate power, right emissions, and that's just the way it works. Okay. That being said, with that, there needs to be a way to control the hot side of the turbo, which is where the wastegate regulator comes in. Okay. Now, Volkswagen and Audi have used three different types of wastegate. And this is very important because you need to understand, because if you look at the operation of the wastegate, one is actually backwards of what you would normally think, right? So we have three different types. You have a pressure operated actuator, which is usually via a spring. You have a vacuum operated actuator, which is going to be using engine vacuum to operate that wastegate. And then electrically operated, where there is absolutely no vacuum being controlled, and it's going to be strictly for the electric motor that controls it, which obviously we know, as electrical concerns go, we do see issues with that, which we'll talk about. Tom's asking, is there a handout for this class? I don't know off the top of my head. I don't think there is. There may be a guide, um, but we can check with one Brandon after this. But continue on here. Older systems use a pressure operated wastegate servo unit to open and close the wastegate valve, right? So the wastegate servo unit is actually the wastegate itself. All right. So there's a return spring that keeps the wastegate closed, right? Charge air pressure regulated by the ECM. So the charge air pressure, you're going to have a map sensor or a charge air pressure sensor that reads how much is going through. It's going to pulse width modulate the N75 valve, right? So N75 valve has a vacuum line. It's going to be a line that goes from the intake side, and it's going to also just be a shutoff valve, and it's going to control that to the wastegate itself. So the ECM, because obviously it's going to be a preset, right? That preset there will essentially control how much that engine is boosting, right? That's where we have engine tunes and whatnot. Okay. Now, ECM determines how much charge pressure passes through the valve by increasing or decreasing the duty cycle on the ground signal. So essentially, you could, if you had and we're talking about P0299, a low boost fault, you can actually scope that N75 and you can see where our duty cycle is going, right? Because we do have issues with N75s, it's electrically controlled, and we want to make sure it's not the ECM doing something weird. But when you think about it, right, it's a return spring that keeps it shut. So those return springs on here, right, is going to be an issue as well. We've seen these where the return springs have now failed and you have it sticking open. So, like I said, these are older style engines like the BPYs, but this is something that we need to know. Okay. So charge pressure is high enough, the duty cycle of the N75 is low enough, wastegate opens and it slows down the turbine, and it basically slows down the charge pressure, because, hey, we've seen the max of what we want to see. The car is happy. That's as much power as you're getting out of, right? Obviously, that's where tunes come in. You get more power, et cetera, et cetera. Now, some of the newer systems, right? It's going to be a vacuum operated actuator, right? Used to open and close the wastegate valve, not one way, right? Or the other. This is going to be used to open and close, but vacuum operated to regulate the charge pressure. So on these systems here, the wastegate valve is open open by using mechanical spring force. Okay. If charge pressure is required, the flaps are closed using the vacuum actuator, right? The wastegate bypass regular valve N75 is going to be pulse width to control that. Now, it's going to constantly use the signals from the charge air pressure sensor, right? G31, and on some charge air pressure sensor 2, G447, right? Because some of these cars are going to be running two intercoolers. Okay, usually charge pressure sensors are either going to be on the charge pipe going up to the throttle body, or unlike twin turbo engine, they're on the intercooler as well. So that's going to be something that we take a look at. Okay, wastegates on the newer engines, and if you look at every single newer engine, and not every new engine uses this, because a lot of the V8s are still using this style vacuum operated, okay, actuators with the N75. Okay. So you're going to see this style on some of the cars, and then you're going to see a lot of these styles on some of the cars as well. Now, this is the newer ones that we see a lot of, all right? Electrically controlled wastegates. Okay. The wastegate actuator is actually a motor. Okay. And all this does is that it's going to open and close the wastegate with the push rod, but it's going to be actuated based on what the ECM is commanding, based on the charge pressure sensor readings, right? So the actuator itself, it has a DC motor. This is a cutaway here of the motor itself. If you've ever taken one apart, or you pull this little plastic cover, and mind you, that is plastic gears inside. Okay, it's on the turbo. We already know what plastic does with heat. So why do we see more electric wastegate failures? It's because of this. All right. Now, to note on that, with the electrical wastegates, we've seen good things coming from it, and obviously we've seen bad things from it, right? But the pressure actuator here, you have the motor, right? It has a Hall effect position sensor in it, right? So it can read in what position it's at, and there's going to be tight tolerances for the push rod to go open or close. Okay. A lot of these, if you've seen them, they will have an adjustable rod. Because here's the thing, we all know that there are people that try to replace the actuator by themselves, adjust the rod to make it work. Now, if you have a higher mileage car, you're not going to want to replace the actuator. Why? And I'm going to tell you why. Because this little bad boy right here, okay, when this rod moves back and forth, right, what you're doing over time, this manifold, right, this part of the turbo, it's going to heat up. There's a bushing in there that this rides in. That bushing wears out, and then this flap starts moving. Okay. Just like the previous generation where we're using a vacuum actuator on here, same thing. This will wear out. And when that wears out, right, they do sell repair kits. There are people that sell repair kits. Okay. There is a pin that you would have to push out or drill out, and then this will allow this rod to come out of the turbo, and you can replace the sleeve and then put a new flap in and reinstall it. But why? At that point in time, with the amount of work you're doing into it, the amount of modification you have to do to that turbo, you're essentially putting a bigger band-aid on that turbo. Okay. Now, the other thing I'm going to talk about here is going to be this, right? This is your N249. This is the bypass valve, right? This bypass valve was ran on the electric wastegate actuators and also the vacuum operated ones. But this is an electric, bypass valve. Now, the issue with the electric bypass valve, what we've always seen, what everyone's seen, is going to be a torn diaphragm, right? And now you get a boost leak from the diaphragm. It's going to bleed off. Now, that may not be a big deal and people just replace it, but you have to remember, like I said, they came up with an updated part. We don't see too many issues with this. And if we do, it's at a higher mileage. when you're seeing this at a higher mileage, right? If you replace just this, we know this bushing is worn. It's probably going to need a wastegate. It's probably going to need a turbo. This is going to fail, right? Or we know that there's internal issues with the electric actuator. Why would we not replace the entire turbo, right? There's no point. You need to replace the entire turbo once at higher mileage. All these little replacement of individual components are it's going to be an issue because you're going to have the car coming back. Now, if this was a lower mileage and we did find this diaphragm torn, which we have seen issues, it's not saying that we have not, and we do see these. If this is torn, when you remove this, make sure you install it in the correct position. This has an installed position. On the newer ones, it actually has a guide pin so it can sit in the correct position. I've still seen people install it in the wrong position and tighten it down. Make sure you install in the correct position or you will get a P0299 fault along with it. All right. So the biggest advantage over the old school pressure actuated with the spring is going to be multiple things. Heat loss is reduced during the warm up phase of the cat converter, right? Because the heat flows through and it bypasses the turbo turbines, right? When you're first starting it up. So the heat's going directly into the cat converter after the engine starts, right? Exhaust pressure can be reduced at part throttle by opening the wastegate valve. So the wastegate valve is obviously not just used to control the amount of boost pressure that you are building, but it is also used as far as emissions, right? Wastegate valve opens briefly during transition to the overrun phase. This keeps the turbine at high speed and it helps reduce lag. But at the same time, right, back pressure at part throttle by opening the wastegate valve, it also controls the emissions on the car. So that's part of the reason why they went to an electric wastegate because it can be controlled a lot faster versus the amount of vacuum that they want going to the actuator themselves. All right. So we've seen these things happen. So, you know, bear in mind, like this is a better image of the wastegate opened up. And if you take a look, right, this rod just goes back and forth based on the position of this motor, right? And if you look, this is the actual DC motor, and it's got a brass gear. This is the only thing that's metal in here. Everything else is plastic. Okay. We have seen issues with this. So realistically, this is one thing to pay attention to when you're getting these P0299 faults or these P334A charge pressure actuator faults, which we're going to be talking about, right? So, the P0299 fault, boost pressure regulation, control pressure not reached, P334A charge pressure actuator, electrical error. So remember, we do have electrical errors, right? We do have issues with it because it is an electrical wastegate actuator. So you can definitely see some concerns with that because of what? Pin fitment, wiring, right? We get rodent damage, whatever the case. What do rats like to do? And for all the people who live in the cold states, even where I am at in California, right? They find somewhere nice and warm. Turbo is always warm, right? Then you got the charge pressure actuator here, which is electrically controlled. You got a harness going to it. What do they love doing? Chewing on wires, right? So this is something that we want to take a look at. So we'll get these two. Okay. Now these are the most common faults, right? That we see. Low boost faults, and then, like I said, a lot of charge actuators are electrically controlled. So we're going to see a lot of those as well. Right. First step in any of these, when you get a car, customers complain of a low boost concern, or, hey, I don't have any power. My car doesn't feel like it's doing anything. We have some issues. Obviously, we're going to scan for faults. Okay. We want to scan for faults. We want to see what faults are actually in the system. Right. 9 out of 10 times, you could probably get a little boost fault. P0299. Okay. Step two, you already got the scan tool hooked up to it, right? We got to go drive and verify the customer's complaint anyways. Let's monitor boost pressure, specified in actual, right? You're going to go into the engine control module. You're going to peruse through the measured value blocks and you're going to look up boost pressure, right? On Volkswagen Audi, I think it's measured value block 90, 10 or 103 or something like that, depending on the car. Some of the UDS is a little bit different, but if you go and look at the boost pressure and you go and drive the car, right? Let's go see. Customers complaint lack of power, right? Maybe it has no faults. Maybe it has no faults because here's the thing. P0299 fault, it won't set right away. Okay. It's going to monitor over a course of multiple drive cycles and see what it does, unless you have like, a wastegate stuck or something, then and you're leaking boost. But you would see that, right, in your charge pressure readings. So go drive the car, monitor boost pressure, right? Now here's the thing. What do we see these in, right? Volkswagen usually does it either kPa or millibar. Most of the time it's millibar. On the factory tool, it shows it in millibar. Even the DrivePro, it shows it in millibar as well. Now, the one thing I will tell you when you start the car up, I don't care what scan tool you have on it, whatever the value is at idle, it's complete crap. Okay, don't believe that value because it's just what the car is sitting at idle. It's a value that they input here. It's a what they call a false value. You actually have to drive it. Okay, the car has to be under load. So go drive it, and then you'll see that the boost specified in actual actually start moving correctly. Okay. Now, when you're looking at it, right, you got to see how many, how far off it is. Because realistically, let's just say it's 1 millibar, right? What's 1 millibar to PSI, right? Not a whole lot, right? But what's like if you see something like 10 millibar, right? Now you're going to be looking at this and it's going to be like, well, 1 millibar to, you know, PSI, now you're almost looking at X amount and it starts picking up these little number nuances. And what's going to do is it's going to flag it. And then the ECM is going to basically set the fault for it. Okay. Now, if you go and you drive it and you monitor your boost pressure and your specified and actual aren't where it's supposed to be, or your actual isn't meeting what the specified is asking for, right? You're pulling back into your shop. Now we're going to check for mechanical, right? Check for signs for mechanical issues. Okay. Believe it or not, a lot of turbo failures is due to mechanical issues, right? Another big lead, um, another big, what's it called? Issue that we've seen as far as mechanical issues too is lack of maintenance. Okay. When you see lack of maintenance, right? Car isn't, because here's the thing. What is the turbocharger lubricated by? Volkswagen Audi turbos are usually oil and coolant cooled, right? You see dirty coolant, you see dirty oil or sluggish, that kind of oil. That's the thing that you're going to be taking a look at, right? This is going to cause premature turbo failures. Obviously, there's other issues with premature turbo failure, but that's what we're going to take a look at. Okay. Now, let's say you don't really see any signs of mechanical damage. The next thing you're going to look at is checking the vacuum system, right? If it's vacuum operated, or hey, now we're going to look at electrical issues. Hey, let's look for rodent damage around the turbo, whatever the case, right? Depending on the style, that's what we're going to take a look at next. Now, here's the thing. Let's say everything checks out correctly. Okay. Most guys want to smoke test the system. Okay. Realistically, you can smoke test all you want. Unless it's a huge leak, you're not going to get any smoke coming out of the system, right? Because it's a turbo system. It's going to be charge air going through there, right? It's being pressurized. So the best thing to do is to get a turbo pressure tester. Okay, they're not that expensive. You can get one of these. You can charge the charge side of the turbo, and then realistically, this is going to be the best way to look for any type of boost leak, right? Because most of the time when you're looking for a boost leak, you got to be under load. right? That turbo's got to be forcing that pressure in. Now, with the turbo system checker, you can do that while you're in the shop. Okay. First and second generation, right? 2-liter turbos. Okay. This right here, wastegate rod. Okay. P0299. Right. This is the most common turbo failure on the 4 cylinders. Right. If you've ever talked to me before, you'll always hear me tell you this, especially on a higher mileage car, finger that wastegate. Okay. That bushing I was telling you about that people try to replace is actually right here. Okay. You see this little hole here? That's where the dowel goes in to keep that bushing in place. Okay. Like I said, it's a pain in the butt to do. Replace the turbo. It's not worth your time. All right. Now, that being said, okay, and if you notice, this is going to be first and second generation because the exhaust manifold, yes, it's part of the turbo, but it bolts and it's a 4-to-1 versus on the third generation, you're going to see the actual, it's just going to be this portion here because the 4 cylinders meet together inside the head. Okay. Common issue on here. Okay. So like that. Okay. A lot of things, just like Chris Martinez here, rev it up, shut it off. You can hear that too. You can hear the turbo. Okay. Depending on how bad it is, you can actually monitor the boost pressure and do it. A couple other ways to check that as well. Okay. Now, the other thing you want to take a look at, okay, is this. When you look at that turbo, okay, this right here, a brand new turbo should have at least, it's about a 3 millimeter gap. Okay. We've seen these wastegate levers seize up in the turbos in either way, open or closed. Usually it's going to be in a open position. That's why you get an under boost fault. If you get an over boost fault, it's usually in the closed position. That wastegate doesn't actuate. Okay. So when you look at it, it needs to have at least 3 millimeters of clearance between the bottom of the lever and the turbo housing. If there's no gap, you got to replace the turbo. Okay. This is not something you can fix. And this is that bushing that everyone keeps talking about. But realistically, like I said, replace the turbo. Most of the time when we see this, you're going to want to replace the turbo. Okay. Now, electric wastegates, right? How many of you guys have seen this? This is on the 1.4 and 1.5s that we've seen multiple issues with. Some of these on the 1.8s and 2 liters, not as much, but most of these are on the 1.4s and 1.5s. Now, with this, the most common issue is that it actually just snaps off right here. Okay. This thing will be pointing down. This rod will just sit there. You actuate, it doesn't do anything. Okay. When you see this, most of the time you can just replace this, especially if it's under 80,000 miles. 80,000 miles, usually for me, we're looking maybe at a turbo issue. All right. Even with this, I would replace the whole thing. Most of the time you can do this. Now, if you replace just the actuator, on these ones, it's not adjustable. So all you have to do is tell the car, hey, turbo's been replaced or the actuator's been replaced. Good to know. When you replace the new turbos with the wastegate actuators, same exact thing. Make sure the car is adapted. Now, for the guys that want to do the special ones with the adjustment and replacing just the actuator, you do need a special tool on the actuator to hold it when you're adjusting the rod, or else it will move and it will never go in range. Okay. Uh, Other than that, like I said, if you're replacing the turbo, adapt the actuator. Another note on these as well, on the 1.8s and 2 liters, okay, you got to check for the adjustment on the turbo ease of movement. Okay. If it doesn't move, it's going to have an issue with the turbo itself, right? We've seen this thing stuck, right? Same thing here, electric wastegate. These are the adjustable ones. Now, the other thing you want to take a look at on here, what you can do is you can actually operate this by going into the scan tool. And then when you go into the scan tool and you actuate the wastegate, what you're going to do is see this. This should move freely, right? Same thing when you start the car up. You'll hear the turbo adjust. If you don't see it moving, this thing's stuck. It needs a turbo. Okay. Key note when you're replacing the turbo. I don't know if any other scan tools have it, but on Otis, they do want you to turn off the oil regulation valve because they want higher pressure for at least the first 1,000 kilometers. Okay. Because what it needs to do is it needs to make sure that the oil is pressurized quickly at full charge. And two, what it's supposed to do is take out the contaminants in the turbo, and then you're supposed to do an oil change after that. Okay. There is a test on Otis that what it does is that it turns off the oil regulation valve so you have higher oil pressure to one first lubrication of the turbo, and two, it takes out all the additional material contaminants that in theory we shouldn't have in a turbo, but it's there. Okay. We've seen these, right? Underboost, overboost issues. We've seen it because your spec actual aren't reading correctly or whatnot. Make sure we check the boost pressure sensors, right? We've seen wiring issues. This is the most common issue. This is where the wire goes into the crimp. Okay. Wires break off right into the crimp. And where this crimp is inside here. The wire will look like it's attached. So if the guys that just do a quick look over with a visual aspect of it, they'll look and see that the connector looks okay. Even if you disconnect the connector and pull it out, sometimes this wire is deep inside here. It doesn't move. You can't tell, okay, until you tug on the wires and then, oops, there's the wire, okay? Need to do a tug test. You need to make sure that the wires are all intact because we've seen this bite multiple people in the butt. You want to make sure that you pull on the wire. Twin turbo V8, okay? Common issue, right? There's a TSB for all the parts that need to be replaced. 204-46-640. All right. This is the strainer that has to be replaced in the crankcase breather because the breather feeds directly into the turbo on one bank only, and it's bank 2, right? Now we think about this, and this is as per Audi. They said this is a normal condition when you look at it. Okay. One's cleaner than the other. The issue with this is that because of this, we have seen issues, right? Because of high pressure fuel pump failures by leaking internally or leaking injectors. It causes fuel to get into the oil, and then we see oil from the crankcase breather getting into the turbos, and it's eating up the seals. That's one. That's the most common on the V8s. Secondly, like I said, that technical bulletin, this strainer needs to be updated in the crankcase breather, and there's an oil control valve, okay, that needs to be replaced in the cylinder head. And what that does is that the oil, it's not getting fed correctly to the turbos, and it's causing premature turbo failures, right? They actually had a technical bulletin on this. You have to update all the components, including new oil return and drain lines. But then we see issues. You'll normally see like scrapage along the compressor housing when you're taking a look at it. But yes, okay. Got to verify that. Also got to verify oil pressure. We've seen oil pressure concerns cause the exact same thing as well with the turbos. Okay. 2.9s or 3 of their single turbos. Okay. Have you guys seen any of you guys seen this one? P0299 faults, low boost faults, right? You pressurize the system, no leaks, right? You go and drive it, and sometimes your boost will fluctuate. Well, here's the issue, okay? This right here is the bottom of the water pump, okay? As we know, the water pumps on these and some of the 4 cylinders, the 4 liters as well, are cool. They have a vacuum controlled diaphragm for the water pump. So what happens is that we're actually getting leakage, and this is usually a sign right here. If you see leakage at that port on the water pump, right? If you pull the hose out, you will see residue or coolant residue, okay? And what happens is you get coolant, right, from the pump, and it goes into the what they call checkpoints or check valves, Okay, and these are the controls. And if you look, what they do is what? They go to the wastegate. Okay. What happens when they go to the wastegate? Well, you're not going to get any boost because it's not controlling, right? It's not operating the wastegates correctly. So a lot of these guys, in order to replace these valves, it comes with the lines. So you're pretty much replacing everything, including the pump, obviously, because that's the main culprit. Now, that doesn't fix everything because there's one more place you need to take a look at, and this is this bad boy. This is the vacuum reservoir. A lot of people miss that because they replace what they see and where the coolant is. But what happens is that you get coolant into the reservoir and it just sits in there. So you go and drive the car again. What happens is now we're getting coolant back into the system because there's coolant in the reservoir. And it does the exact same thing again, and you still keep getting low boost. Okay. So that's what you'll want to take a look at. This is a common issue on the 2.9s and the 3 liters is the coolant migration. And we've seen a couple of these on the 4 liters as well. Okay. Another thing for 4 liters and the 2.9 3.0s, but this is more of a common issue with the 4 liters as far as um, the vacuum supply goes, right? Okay. We've seen issues with collapsed hoses, right? And with collapsed hoses, it's going to cause irregular readings to the ECM. And then what happens with that, the ECM is now calculating it incorrectly. And now your wastegate is going to be controlled incorrectly because of the vacuum reading that it's getting. Okay. Now, the reason I have 13 highlighted here, this is the most common issue on the 4 liters where the line that goes to the coolant pump is actually collapsed. And sometimes it's hard to see. There is an updated coolant or a vacuum line for that. Okay. That collapsed vacuum line. What happens with that? There, it was poor manufacturing basically, but it's the same thing, right? You think about it. So rubber vacuum line, it's off an engine, it's right in the middle of an engine, it's gonna wear down. Okay. So this is something to always check. And like I said, right, you want to check vacuum at multiple places, right? Where your vacuum differentiates, that's where we're gonna see the concerns and the issues here. Okay. So that is something that we definitely want to take a look at when diagnosing these things. But essentially, this is what we see. Okay. I don't think there's that many other 4 liter 2.9 issues. And obviously not that many 2 liter issues, obviously with the turbo, other than the wastegate flap, um, the electrical controls on it, we need to verify the wiring. Same thing with the electrical control and the electric wastegate. We've seen issues with it. So we want to make sure that everything is good, okay, when diagnosing these things. Um, Other than that, that's the end of our webinar. Obviously, if you guys are interested in any of our product, DrivePro 2, Cardiac Pro, IVS or technical support or any of the remote assistance stuff, you can scan our QR code. It'll take you to a link with information. Other than that, I didn't see too many questions. If you guys have any questions, free to answer them. Um, but yeah, if you guys don't really have any questions, thank you guys for joining me this evening. What was that? This last bit of information on 3029. Yeah, the 3029. The biggest thing on the and I'm gonna touch on this on Jose's question. Do you replace the vacuum reservoir every time? Um, I would say yes. A lot of times, if so, the 2.9s and 3.0s, the most common issues is going to be coolant migration from the vacuum operated coolant pump. Okay. So we've seen the vacuum operated coolant pumps fail left, a lot of times you'll see it because of an overheating concern, right? The diaphragm is torn or whatever the case, and then basically you don't have issues on it or you see issues with overheating. And then essentially what happens is you're going to see the coolant go through the coolant pump and it's going to be passed through the entire vacuum system. Okay, that's the most common issue on 2.9, and it will cause that P0299 low boost fault. So Basically what you want to do when you do get that and you replace all the vacuum lines, because to get the check valves, it's a complete vacuum line with the check valves and the actuators. When you pull the vacuum lines off the solenoids, if there's coolant in there, replace the solenoids, because the coolant will get in there and it will get all crusty and it won't move. But yes, the reservoir, even you know, I've heard of people shaking it out to see if they can get all the coolant out. You'll still get some coolant left in there. It's better just to replace the reservoir. It's one of those things, better safe than sorry. Okay. But that's pretty much it. Generation. Oh, yes, generation of new crankcase breeder design, new 3 liter turbo, the 2 liter turbos on the 4 cylinder. Okay, if the way you've seen it, the purge valve, okay, is hooked up right to the crankcase breather. And then what happens is that when that breather fails, and what we've seen is the line going to the turbo, that breather fails, and basically you're pressurizing the system. This is where we've seen these plastic oil pans crack because of the excessive crankcase pressure, because of the boost pressure, right? There's a check valve that fails. And then what happens is now you're getting that excessive pressure as well going through the evap system, blowing out the purge valve. And on some of these, we've had issues with either the tanks collapsing or even some of the tanks cracking. I think that's it. And yeah, this video should be on YouTube. It is recorded, so it should be posted on YouTube. All right. Once again, guys, thank you for joining us this evening, and hope to see you guys next time. Last question, Jose. Is there a crankcase pressure spec? Volkswagen, Audi they don't give out crankcase pressure spec. Um, you can email me. I think we have a list of known good crankcase pressure specs, but I want to say it's about a 95 to 100 millibar is usually what we see on those. Um, as far as known good, but you could always shoot me an email and I can check and see what we have on our list. All right. Again, thank you guys for joining us, and I'll see you guys next time. Brandon.